we are going to learn a new concept. A circle, relation between a circle and a quadrilateral. A quadrilateral ABCD is given. And a circle with the center O. Consider the quadrilateral ABCD. Where does it lie? All the vertices of this quadrilateral are points of the circle, or the quadrilateral is inscribed in the given circle with the center O. What do we call such a quadrilateral? Such a quadrilateral is called cyclic quadrilateral. What is cyclic quadrilateral? A quadrilateral whose vertices are points of, all the vertices are points of the circle. A quadrilateral whose all the vertices are points of a circle. A, B, C and D are points of the circle. Such a quadrilateral is called a cyclic quadrilateral. Or if a quadrilateral is inscribed in a circle, then it is a cyclic quadrilateral. Now we are going to learn the cyclic quadrilateral theorem. What about angle A and angle C? They are opposite angles of quadrilateral ABCD. What about angle D and angle B? They are also opposite angles of quadrilateral ABCD. What is the relation between the sum of these two angles? Now, according to the result we have already learned, what is the sum of the measures of these two? Central angle. This is the consider arc ABC. What is the angle subtended by arc ABC at the center? This. Which is the angle subtended by arc ABC, other side of the arc, other part of the arc of the circle? Angle ADC. What is the relation between these two angles? If this angle is 2x, that is angle subtended by an arc at the center, this is double the measure of the angle subtended by the same arc on the other part of the circle. So if this angle is 2x, this is x. Then what is the measure of this angle? This angle is subtended by the arc ADC at the other part of the circle, and the measure of this angle, or which is the central angle, the angle which is the angle subtended by arc ADC at the center of this angle. So if this measure is 2y, then what is this measure? Y. What is 2x plus 2y? Angle around a point 360. 2x plus 2y equal to 360. That is 2 into x plus y equal to 360. X plus y equal to 180. These are the opposite angles of a cyclic quadrilateral. X plus y equal to 180. The sum of x and y is 180 means these two angles are supplementary. X plus y. That is, cyclic quadrilateral theorem says, in a cyclic quadrilateral, the opposite angles are supplementary. In a cyclic quadrilateral, the opposite angles are supplementary. That is, angle A plus angle C plus angle B plus angle D equal to 180, because they are opposite angles of the cyclic quadrilateral. Then what about angle A and angle C? They are also opposite angles. So what is the sum? Angle for angle A plus angle C is also 180. That is, angles opposite angles of a cyclic quadrilateral are supplementary, or their sum is 180. Using the theorem we have already learned, we can prove this. That is, which theorem we use here? The angle subtended by the arc at the center is double the angle subtended by the arc at the other part of the arc of the circle. Now, what can be its converse? If in any quadrilateral, suppose we are given a quadrilateral PQRS, if the opposite angles of this PQR, that is, if angle P plus angle R equal to 180, then it is a cyclic quadrilateral. If angle S plus angle Q equal to 180, this is called a cyclic. Such a quadrilateral is called a cyclic quadrilateral. This is the converse of cyclic quadrilateral theorem. That is, if in any quadrilateral, if the opposite angles are supplementary, then it is a cyclic quadrilateral. That means it can be inscribed in a circle, or for such a quadrilateral, all the vertices are on the circle. For example, a square is a cyclic quadrilateral because opposite angles are supplementary. A rectangle is also a cyclic quadrilateral because its opposite 90 plus 90, 180. So read that section cyclic quadrilateral from the text and then do the examples and the exercises. Thank you.